Imagine a scent, a highly specific, unmistakable chemical signature drifting through the cold night air. For millions of years, this specific scent has meant only one thing to the common brown rat: absolute, terrifying, imminent death. It is the smell of feline urine, the scent of the apex predator. Evolution has hardwired the rat's brain to react to this smell with a violent, involuntary panic. The moment those molecules hit the rat's olfactory receptors, an alarm bell rings in its amygdala. The heart rate doubles. Cortisol floods the bloodstream. The rat freezes, assesses the environment, and then flees in the opposite direction with every ounce of energy it possesses. This isn't a choice. It is a biological imperative. It is the algorithm of survival. But tonight, something is wrong. The rat smells the predator. The chemical signature is processed. But instead of freezing, the rat stands up. It sniffs the air. And then, it does the impossible. It doesn't run away. It walks directly toward the smell. It approaches the shadow of the cat, completely devoid of fear. In fact, its brain chemistry suggests it is feeling something else entirely: intense, fatal attraction. It walks willingly into the jaws of its murderer. In episode 1, we learned how the cat manipulates us. In episode 2, we saw how we engineered the dog. We thought we understood the hierarchy of control. We thought the game was played by animals we can see, touch, and selectively breed. We were wrong. Welcome to episode 3. Today, we look at the animal that should fear the cat, but doesn't anymore. And we uncover a truth so disturbing, it shatters our entire understanding of behavior, choice, and free will. To understand the magnitude of what is happening to this rat, we must first understand the architecture of fear. Fear is not a weakness. Fear is the most perfectly polished tool in the evolutionary toolkit. Over millennia, the universe has ruthlessly eliminated animals that were not afraid enough. The ancestors of modern rats survived specifically because their fear response was flawless. In the rat's brain, fear is processed in a small, almond-shaped cluster of neurons called the amygdala. The amygdala doesn't reason. It doesn't debate. It is a biological tripwire. When a rat smells a cat, the olfactory bulb sends a signal directly to the amygdala, bypassing the higher cognitive functions of the brain entirely. The rat doesn't think, "Oh, that smells like a cat, I should probably leave." The rat is already running before it even consciously realizes what it smelled. This system is locked tight. It is impenetrable. It is the fundamental code of the rat's existence. So, what could possibly override millions of years of perfectly engineered survival code? What could reach inside a living brain, turn off the alarm system, and rewire terror into desire? Scientists first began noticing this anomaly in the late 1990s. Laboratory rats that were exposed to the scent of cats were not reacting normally. At first, researchers thought the rats had simply lost their survival instincts due to generations of breeding in captivity. But when they tested wild rats, they found the exact same phenomenon. A significant percentage of the wild rat population was displaying suicidal behavior. When researchers placed these anomalous rats in a maze with the scent of rabbit urine on one side and cat urine on the other, normal rats avoided the cat scent like a plague. But the anomalous rats didn't just ignore the danger, they actively sought it out. They spent more time exploring the area that smelled like their deadliest enemy. Even more disturbing, neurological scans revealed that the fear centers of their brains were not simply deactivated, they were hijacked. When these rats smelled the cat, the neural pathways associated with sexual arousal and reward were lighting up. The terror hadn't vanished. It had been weaponized. The rat had been reprogrammed to fall in love with the scent of its own death. To find the culprit behind this impossible behavior, scientists had to look smaller. They had to look under a microscope. They found a single-celled protozoan parasite. Its name is Toxoplasma gondii. Toxoplasma gondii is one of the most successful parasites on the face of the earth, but it has a very specific, highly inconvenient biological problem. It can infect almost any warm-blooded animal on the planet: birds, mice, dogs, cows. But it can only sexually reproduce in one specific environment in the entire known universe: the intestinal tract of a feline. If Toxoplasma gondii finds itself inside a bird, it cannot complete its life cycle. If it finds itself inside a human, it cannot complete its life cycle. It must, at all costs, get inside a cat. But imagine you are a microscopic organism. You have no eyes, you have no limbs, you have no brain, and you are currently trapped inside the bloodstream of a rat, an animal whose entire existence is dedicated to actively avoiding cats. How do you get your host to deliver you into the stomach of the exact creature it has evolved to fear the most? You don't just kill the host. A dead rat is useless. You need the host alive, mobile, and willing. You execute the most sophisticated neurological heist in the natural world. The journey of Toxoplasma gondii inside the rat is a masterclass in bioinfiltration. When the parasite first enters the rat's body, usually through contaminated food or soil, it faces the immune system. But Toxoplasma is a shapeshifter. It disguises itself, sneaking past the rat's white blood cells. But its true target isn't the blood, it's the command center. The parasite travels up the spinal cord and approaches the blood-brain barrier. This is a highly selective microscopic security wall designed to keep pathogens out of the delicate neural tissue. It is the fortress guarding the mind. We still don't completely understand how, but Toxoplasma gondii breaches the wall. It acts like a biological Trojan horse, tricking the rat's own immune cells into carrying it directly into the brain tissue. Once inside the brain, the parasite doesn't just wander aimlessly. It navigates with horrifying precision directly to the amygdala, the fear center. Here, the single-celled organism begins to form microscopic cysts. It anchors itself into the neural pathways. It is performing brain surgery from the inside. Now that the parasite has infiltrated the hardware, it begins rewriting the software. The cysts begin to secrete an enzyme. This enzyme is a catalyst for the production of L-dopa, which is a direct precursor to dopamine. Dopamine is the neurotransmitter responsible for pleasure, reward, and motivation. The parasite essentially floods the rat's fear circuitry with a massive, localized dose of pleasure chemicals. It short-circuits the connection between the olfactory bulb and the panic response. When the rat smells cat urine, the signal travels to the amygdala, just like it always has. But instead of triggering a cascade of cortisol and terror, the parasite intercepts the signal. It releases a burst of dopamine. The rat feels a rush of euphoria. The scent of the predator is suddenly linked to an overwhelming sensation of reward and attraction. The parasite has taken the steering wheel. The rat is no longer acting on its own behalf. It has been transformed into a biological taxicab, driven by a microscopic organism with only one destination, the mouth of a cat. The rat walks out into the open. It seeks out the cat. The cat pounces. The rat is eaten, and Toxoplasma gondii is successfully delivered into the feline digestive tract, where it can finally reproduce. Mission accomplished. Let's step back and look at the philosophical nightmare this creates. When we watch the rat walk toward the cat, what are we looking at? The rat isn't a robot. It isn't dead. Its muscles are functioning normally. Its heart is beating. Its eyes are open. From the rat's perspective, it isn't being forced to do anything. It isn't feeling pain. In fact, it's feeling exactly the opposite. It is following its desires. It is making a choice based on what feels good in that exact moment. But that desire was artificially implanted. That choice was written by a single-celled organism sitting in its amygdala. This forces us to ask a terrifying question. What is behavior? What is free will? If a microscopic parasite can change the fundamental personality of a mammal, if it can turn its deepest fear into its greatest desire just by tweaking a few neurotransmitters, then what does that say about the concept of autonomy? We like to believe that behavior is the result of character. We believe that we make choices based on our unique consciousness, our past experiences, our soul. But the story of the hijacked rat proves that behavior can be nothing more than a chemical equation. Change the variables, and you completely change the animal. The rat believes it is free. It walks to its death willingly. Because the ultimate form of control isn't putting someone in chains. The ultimate form of control is making them want to wear the chains. If this phenomenon were limited to rats, it would merely be a morbid curiosity of the natural world, a dark, fascinating trick of biology. But nature rarely invents a weapon this powerful and only uses it once. Remember the biological problem of Toxoplasma gondii. It can infect any warm-blooded animal. It is completely indifferent to the host it uses. If it gets inside a bird, it rewires the bird. If it gets inside a sheep, it rewires the sheep. It is a universal operating system override. Recently, scientists observed a troop of wild chimpanzees. Chimpanzees have a natural, deeply ingrained terror of leopards. It is their apex predator. But researchers noticed something chilling. Certain chimpanzees in the troop were no longer afraid of leopards. In fact, they were deliberately walking toward areas where leopards were known to hunt. When researchers tested the blood of these suicidal chimpanzees, they found exactly what you are thinking. They were infected with Toxoplasma gondii. The parasite was running the exact same script. It was hijacking the brain of one of the most intelligent primates on the planet, flooding its system with dopamine, and marching it straight into the jaws of a feline predator. The cat controls us from the outside. We control the dog through genetics. But Toxoplasma gondii operates from the inside. It proves that behavior does not equal freedom. It proves that the mind can be hacked, reshaped, and weaponized without the host ever knowing they've lost control. The rat thinks it is making a choice. The chimpanzee thinks it is making a choice. But what about you? What if I told you that this exact same microscopic parasite, this silent, brain-altering puppet master, is currently living inside the brains of approximately 1/3 of the global human population? What if I told you that it has already breached your blood-brain barrier, formed cysts in your amygdala, and is quietly dripping neurotransmitters into your mind right now? Is it changing how you think? Is it changing who you vote for? Is it changing who you love? What is behind these behavioral changes, and are your thoughts even your own? Join us in episode 4 as we turn the microscope away from the rats and point it directly at ourselves.